Almost half the plastics that we use are thrown away after just a single use. The problem is there is no away. And plastic can take hundreds of years to degrade. So every single piece of plastic that has not been recycled still exists. I'm Oliver Steeds, and I've come to Ireland to investigate how we can convert our waste plastics into fuel.
We live in an age of plastics. Polyvinyl chloride is found in anything from pipes to window frames, polypropylenes in margarine tubs, even fibres for carpet, polystyrenes in building insulation and protective packaging, and we find polyethylene in anything from our plastic bottles to bin liners. They all have one thing in common. They were once oil, a mix of chains of carbon and hydrogen, which all have different properties depending on their structure.
Much of this waste can be recycled into new products, but some of it, known as end-use plastic, currently has no second life and ends up in landfill, where it can release hazardous chemicals into the environment. So what plastics can be used for fuel?
This is an example of the type of plastic that we're sending away now to be used as a fuel. So what we have is various colours of plastic, red, greens, blues and whites. It's hand-picked out from the paper and the rest of the material, and it's baled up.
This is Cynar in Portlaoise, Ireland, where end-use plastic is given one more life.
Some of the plastics end up here in Cynar's processing plant. Michael's the CEO. Michael, what are we looking for here?
Well, these are bales of plastic that come in from waste management companies into us for processing into diesel fuel. So what this normally would go straight into a hole in the ground. Doesn't make any sense. No. So what we have to do with this now is reduce it, size reduce it. So it comes into us like this, like that, size reduce it. So it's the correct size to go into the process. It makes it easier to handle.
Cynar can process 1 tonne of end-of-life waste plastic every hour and turn it into this, a mountain of 15mm flakes of clean plastic, where it's sucked up through this industrial vacuum and piped into a furnace.
So you can feel the heat from here. This is a simple, what is happening is the material is being delivered in. There's a screw mechanism and it's being pushed whilst heated along this barrel. It starts life at around 180. At 300 degrees, 300 to 310, it's leaving this particular extruder. And it's like a hot chewing gum consistency.
The plastics are now ready to be converted into fuel.
Well, we're looking down here really to the heartbeat of the process. It's the pyrolysis vessels. We are heating the material up to a vapor temperature of about 385, 410. That then produces a hydrocarbon vapor.
The key point with pyrolysis is that there is no oxygen present, so the superheated plastics can't burn. Instead, the molecular bonds of the long carbon chains that make plastic what it is break apart, returning them to the various smaller hydrocarbon chains that they were created from in the first place. The different length hydrocarbon chains can then be separated.
The vapor that comes off the pyrolysis vessels passes through a unique baffle arrangement that's inside these contactor vessels here. So we're cracking carbon chains, so the heavy material is not allowed to leave and join the vapor line to the distillation column until it has the correct profile.
What happens in the distillation process?
The hydrocarbon vapor that leaves the top of the contactor vessels then travels through a vapor line, and that vapor line then arrives into our distillation column. In there, the condensable material then is liquefied, and we take off our diesel fuel off the bottom of the distillation column. Further up the column then we have our light oil, and then our non-condensable gases leave the top of the distillation column, and it's those gases that we clean and use in the furnaces to heat the pyrolysis chambers.
How efficient is this process?
For every tonne of plastic we get about 800 litres of diesel.
When I think of plastic, I often think it's very toxic. What happens to all those toxins?
Well, we are not burning plastic, we're heating and paralysing plastic. So we're producing a vapour rather than oxidising the material when you burn it with a flame.
The only byproduct is a non-hazardous char, the pigments and fillers from the plastics that Cynar hope will soon be given a second life as either man-made tiles or pigment for decorative concrete.
Well, I now have a litre of diesel, but I want to put it through some tests. So I brought in a team from University College Dublin.
So what we'll do is we'll show you the performance of it, running on the emissions of it, running on normal diesel. We'll put some of this fuel into the tank, we'll run the tests again, and we'll show you the performance and the emissions running on the synthetic diesels.
Key ones will be carbon monoxide.
Carbon monoxide, carbon dioxide.
Carbon dioxide, yep.
Hydrocarbons, HC.
Yep.
And oxygen.
now got the comparative figures. One of the most striking things is this hydrocarbon footprint.
Yeah.
499 parts per million
Yeah.
on conventional diesel, and with synthetic diesel mixed in, it's 294. What does that mean?
What it means is, quite simply, the synthetic fuel is burning more efficiently.
And carbon dioxide, there seems to be a massive reduction in carbon dioxide emissions using synthetic fuel.
Because that's mainly due to the dilution with the oxygen. As you saw, the oxygen went up in it. So again, because the fuel is burning more efficiently, the engine's doing the same amount of work, but using a little bit less fuel.
So, Doctor, overall, your assessment?
The assessment of the fuel, the synthetic fuels, it's definitely one of the fuels for the future. It's a nice, clean fuel, clean burning as you saw from the emissions. The key benefit is that you're recycling carbon. So carbon that might have gone in the plastic, gone into landfill, or been disposed of by incineration, is now being recovered. It's been used as a synthetic fuel, which means you don't need to take as much fossil fuel out of the ground. We have a saving on that. We can use those fossil fuels for maybe something else in the plastics industry, in the pharmaceutical industry.
Sina are currently able to produce 10,000 litres of synthetic fuel a day in this plant, but they're soon opening up new and bigger plants in the UK. With 15 million tonnes of plastic still going into landfill in Europe every year, they're not short of their raw materials, but the political and consumer mindsets need to catch up. The vast majority of plastic waste is still not recycled, but there does seem to be a solution here if only society and industry can look at end-of-life plastics not as a waste, but as a product that has value and something that does have use.